NASA detected a mysterious object.
3IATLAS is moving closer to the sun. There's still so much we don't know.
Comet, asteroid, or something else.
A mysterious object from interstellar space is pulsing gas like clockwork.
One Harvard professor is raising the theory this may actually be a piece of alien technology.
Steering toward Mars. If it hits, it could unleash energy equal to 2 million megatons of TNT. NASA and Harvard are watching closely, because this comet might not be a comet at all. A visitor from the void. For most of history, the night sky was a map of myths. Every light, a symbol. Every comet, a curse. Ancient cultures feared them as divine warnings, serpents slithering across the heavens. But in October 2024, that symbolism might become reality. A visitor is coming, not from the asteroid belt or the Kuiper belt, but from the deep interstellar dark, an object on a path that defies expectation. It has no name rooted in legend, only a catalog number. 3IATLAS. But the numbers trailing behind it are louder than any myth. This is no ordinary rock. It's fast, it's changing course, and it's heading straight toward the red planet, the lonely island in our solar system, where we've staked our next great hope. At first, scientists thought it would pass harmlessly, but then something shifted. Harvard physicists and NASA analysts noticed small changes in its motion. Too precise, too deliberate. It began to accelerate in bursts, like a swimmer adjusting course midstream. And the closer it got, the stranger it behaved. What if this isn't just a piece of ice tumbling through space? What if it's something else? Watching, waiting, calculating? The first red flag. In early 2023, telescopes across 2 continents picked up a faint, fast-moving object. One signal came from South Africa, the other from the Purple Mountain Observatory in China. Both locked onto the same blur, an icy fragment speeding in from deep space. The object was quickly designated 3IATLAS, the third interstellar visitor ever confirmed. For a few weeks, it was just another celestial curiosity, a data point, a footnote. Then, Harvard's Center for Astrophysics ran the numbers. The orbit didn't make sense. Harvard astrophysicist Avi Loeb and his team noticed something unsettling. Unlike natural comets that follow gravitational arcs, 3IATLAS seemed to be subtly veering off course, not wildly, but consistently. The Jet Propulsion Laboratory confirmed it. Every new observation required a minor correction, as if the object was reacting to something, or steering. Then came the projection that turned quiet interest into quiet panic. According to early simulations, 3IATLAS wasn't just passing through the solar system. It was on track to intersect with Mars in late 2025. The chances were low, but not zero. And that was enough. Because in the language of planetary defense, a 0.1% impact probability isn't dismissed. It's escalated. Behind closed doors, teams began refining the data. But the red flag had already been raised, and what they found next only deepened the mystery. A comet that defies logic. Comets are chaotic by nature. They vent gas as sunlight warms their icy surfaces, spinning unpredictably, shedding tails that flicker and sway. But 3IATLAS isn't behaving like that. Its tail isn't wild. It pulses, like a heartbeat. Every 17 minutes, gas jets erupt in near-perfect rhythm. Not random, not chaotic, synchronized. That rhythm set off alarms. When researchers at Gemini South Observatory in Chile captured spectroscopic readings of the object's tail, they didn't see the usual signatures of dusty ice. Instead, they found carbon dioxide emissions far higher than anything recorded in typical solar system comets. And those emissions weren't drifting. They were firing, in the exact direction needed to steer the comet closer to Mars. Natural outgassing doesn't work like that. It doesn't keep time. It doesn't adjust trajectory. Yet every new observation showed the same thing, an object accelerating ever so slightly but consistently toward a narrower path. Some called it coincidence. Others suggested unusual venting patterns or unknown physics. But even those explanations failed to account for the consistency, the precision. It wasn't just moving. It was aligning with Mars's orbital plane, meter by meter, week by week. And as the weeks passed, the predicted flyby distance shrank. First a few million kilometers, then hundreds of thousands, then less. Whatever this object was, it wasn't playing by the rules of cometary science. And the more it moved, the more it looked like it knew where it was going. Inside the silent panic. Publicly, space agencies remained calm. Press releases spoke of routine monitoring and ongoing orbital refinement. But behind the scenes, the tone was different. At NASA's Jet Propulsion Laboratory, engineers began repurposing the Mars Reconnaissance Orbiter as a forward scout. Its cameras and sensors aimed not at Mars, but at deep space. High-gain radar systems at the Goldstone Deep Space Network were quietly retasked to ping the object's core. What they found didn't match expectations. Instead of the soft, fuzzy echoes typical of ice and dust, the radar returned hard, metallic signals. They bounced back with strength and clarity. Something dense was hiding beneath the icy shell, something that reflected like metal. Leaked internal memos described the returns as unlike any echo we've ever recorded. The data was quickly classified. Mission planners were told to track, not speculate. But the speculation was already spreading. If this object had a core made of metal, or worse, of alloys that shouldn't exist naturally, it could point to something far more engineered than frozen. Meanwhile, ESA's Mars Express began photographing a strange formation high above the planet. 3 glinting points of light, fixed in a triangular pattern, orbiting silently. At first, they were dismissed as sensor noise or cosmic rays, but when they reappeared on 3 consecutive orbits, always in the same alignment, the conversation changed. Some insiders whispered they might be probes released from the object on an earlier pass. If true, this wouldn't just be a scientific anomaly, it would be the first coordinated interstellar maneuver ever recorded. No announcements were made, no warnings issued. But across agencies and observatories, a new term began to surface. Not comet, not asteroid, but vehicle. Loeb's theory, a probe, not a comet. Long before 3IATLAS entered the picture, Harvard astrophysicist Avi Loeb had already stirred the scientific world with a radical claim that Oumuamua, the first known interstellar object, might not have been natural. Its strange acceleration, its lack of a tail, its unusual shape, all pointed, he argued, to something artificial, a relic, a messenger, perhaps even a discarded probe from another civilization. The academic world bristled, but Loeb didn't back down. And now, with 3IATLAS behaving in even stranger ways, his hypothesis no longer felt like science fiction. It felt like foresight. Loeb and his team published a working paper, circulated ahead of peer review, that proposed a chilling possibility. What if 3IATLAS wasn't just mimicking guided movement? What if it was guided? Each gas pulse, according to their models, wasn't the result of chaotic venting. It was controlled, thrust expelled deliberately to change course. Like a spacecraft using reaction control jets, not ice sublimating at random. The timing, the direction, even the power required, all suggested coordination. Their calculations also showed something unexpected. If the object continued pulsing at its current rhythm, it would shave its missed distance from Mars down to under 50,000 kilometers, closer than some of Mars's moons. One final burst of thrust, even minor, could tip the trajectory into a direct impact. The energy needed? Just a fraction of what SpaceX's Starship uses to launch. To some, this was confirmation of Loeb's larger argument, that we are already being watched, tested, or perhaps simply ignored by ancient machines on long-forgotten autopilot. To others, it was still an overreach. But what no one could deny anymore was this. If 3IATLAS is acting like a probe, it must be analyzed like one. Because in cosmic terms, Mars is right next door, and something is approaching fast. The Mars countdown. The clock is ticking. According to the most recent projections, September 26, 2025, is the moment of closest approach. By then, 3IATLAS will have traveled billions of kilometers across space, guided by gravity, or perhaps by design, toward a planet we've spent decades trying to understand. The current predicted distance? 1.95 million kilometers. In astronomical terms, that's a near miss. But in orbital mechanics, it's a knife's edge. A slight nudge, just 10 kilometers per second of lateral velocity, could close that gap completely. At its estimated mass of 10 billion tons, an impact would be catastrophic. The object's speed relative to Mars, over 57 kilometers per second, means the collision would release an energy burst equivalent to 2 million megatons of TNT, enough to excavate a crater 60 kilometers wide, vaporize entire regions of the Martian surface, and launch debris into orbit, or beyond. The shockwave alone would be enough to disrupt Mars's thin atmosphere. Satellites, landers, rovers, all could be rendered blind, silent, or destroyed in a matter of seconds. But the threat isn't just geological. Mars hosts some of humanity's most ambitious exploration projects. The Perseverance rover, the Ingenuity helicopter, orbiters scanning for signs of ancient life, and communications relays critical to future missions. A single strike could undo decades of investment and delay future crewed missions by years, perhaps longer. And then there's the unknown. If any fragment of 3IATLAS were to contain engineered material, be it nanotech, alien microbes, or something stranger, then the fallout wouldn't stay confined to one planet. Some simulations even suggest that debris could be flung into interplanetary space, reaching Earth's orbit within a decade. The countdown isn't just about Mars anymore. It's about what happens when something from another star system decides to make contact, with stone, with science, or with silence. What we know now? The panic didn't last long, not officially. As more observatories turned their instruments toward 3IATLAS, the data began to settle. Each new positional fix allowed for more precise orbital predictions. By late 2023, both NASA's JPL and the European Space Agency publicly confirmed that the object would not collide with Mars. Its closest approach, they said, would be distant enough to pose no threat. Headlines faded, the sense of urgency evaporated, but not everyone was convinced. Even as the official projections widened the safe gap, some anomalies remained unresolved. The pulsing emissions were still there, the ultraviolet brightening still unexplained, the radar echoes, the metallic signature, the triangular glints above Mars. None of it had easy answers, and while the impact risk had been revised, the behavior of the object hadn't. It was still accelerating in controlled bursts. It was still tracking an unnaturally refined course. What troubled researchers wasn't the threat of destruction, but the implication of intent. Natural objects don't self-correct. They don't steer into tighter orbits. And they certainly don't mimic the behavior of spacecraft using sublimated exhaust to navigate the inner solar system. The consensus was fractured. Some argued it was an extreme, though natural, example of cometary activity. Others suspected unknown physics. A few, like Loeb, refused to back down from the possibility of something designed. But even those clinging to conventional models were forced to admit, 3IATLAS doesn't fit the pattern. It never did. So, while the collision may be off the table, the mystery remains. Because every day it moves closer, and every burst of gas it releases still whispers a question no telescope can answer. Whether guided by physics or purpose, 3IATLAS has already changed how we look at the sky. If it's just ice, it's extraordinary. If it's something more, it's historic. Either way, the question lingers. What else is out there, and what's already on its way?